Okay, so for today's lesson, I'm going to talk about orthographic drawing, or orthographic projection, as it's sometimes known as. I've pre-drawn an item. I've chosen a plug. Reason being, everyone in the house, everyone at home should have something similar to this, a plug adapter. This is an Apple one, but you could have one that's similar. And I've pre-drawn this out just to save a bit of time so the video doesn't go on forever. So just a little bit of a backstory about orthographic beforehand. It's basically used mainly in industry, and it would be almost like the blueprint of a product. So if I was manufacturing this plug, I perhaps would design it and send it off to a factory, and then they would, based on my plans that I give them, they would you'd be able to, accurately make it, and there'd be no mix-ups because you would have a top view, a front view, and a side view. Okay, this particular type of orthographic is known as third angle. There is another one called first angle as well, but we're just going to worry about this one for today. This is the main one that I usually teach. As I say, I've sketched some elements out and I've got these dotted lines. The reason for those will become clear in time. So when I say about drawing in orthographic, the one thing I always use is this sheet here, because just to kind of work out the layout, you're laying out your page as so. So you would have your top in the top corner. You can see I've put these lines so it's parallel. I'm not having this item here, this item off to the side up here, this item over here. You want these as parallel lines. Forget about this part for the time being. You want parallel lines, front, top, and then front and side. And as I say, if you're unsure how to place them, have a look at this, or you can pause this and make sure your image is the same. You take your item and you twist it that way, okay? So there's your front, there's your side. I don't want it that way. I want to see as if you are twisting it like this. Doesn't matter what your item is, the same rules apply. Then when you're doing your top, there's your front, and you would twist it so your top view would be like so, okay? So that's this. I'll show you an example of a piece of work that a student has done in the past. We have these cardboard money boxes. We have a few that have been donated to the school, and the good thing is they work really well as an orthographic drawing. So you can have your view like this, your top view, your front view, and your side view, okay, laid out. We're going to talk about measurements in a later video, so don't worry too much about measurements. And then we're going to talk about the different types of lines. But for now, the takeaway, the thing you need to take away is placement, okay? So that's that. As you can see, I've laid these out. Now, you may have already guessed, or you may be able to work out these dotted lines, but effectively, I've drawn this one in to begin with just to help me out. But whatever your shape is, I've done a diagonal line going through, temporary. I'll rub that out at the end. And the reason is so that I can mirror wherever this placement is. So with this plug, if this part sticks out this much, if I do a dotted line, I know that looking from the top, it should stick out as much as this, okay? So therefore it is level, okay, and it's symmetrical. And then also that plug there, when I move down and I turn this to the front view, that should line up. So that should be a straight line. That part would be there. These two here would be here and here respectively, and then they would be parallel and they would fit in there. You can see I've drawn two light lines and that should line up. So that's the biggest takeaway, I would say. One of the biggest takeaways is make sure all of your items line up. You can see this plastic here, plastic casing up here, so therefore this will fit within here, okay? The other thing I'm going to say is that this is a scale drawing. You can see scale 2:1, okay? Obviously that means that this is not actual size. What it means is, in this case, I'm drawing it twice the size. So if this measurement here is 40 millimeters, it would be 80 millimeters. Okay, so it does require a bit of working out. And when you pick your product, not a bad idea. And I've done this really quickly. I just did this, my own little cheat sheet, and I just drew, you don't need to see those, but I drew that out on the side there just so I make sure my measurements are correct. So I know, okay, as I said, that's 40, so it's going to be 80. That height, I believe, is also 40, so therefore it'll be 80. If this is 5 millimeters, I'll make it 10, so on and so forth, okay? Pretty straightforward. So the reason is you would have a scale drawing. It could be because you've got a minuscule component, let's say like a little microchip that could be on a circuit board, and you want to have a orthographic drawing. So you could have scale 10 to 1, meaning it's 10 times bigger, or it could be 100 to 1, or it could be you are doing a drawing the other way around. So you are doing a drawing of, let's say, a piece of furniture, like let's say a table or a chair, and you want to draw your front, your top, your front, and your side, and that would be the other way round. So that could be, the numbers were the other way around, so it would be 1 to 2 or 1 to 5, okay? And that means, obviously, you are drawing a picture that then the item would be, in reality, 5 times bigger than the drawing on your piece of paper. Hopefully that makes sense. So, as I said, I've planned this out. Now, I've drawn this just for, to save time. There's also a little dimple on the side of this plug. I haven't drawn that. You can if you want to. The reason I haven't is because when you look front on, you can't actually see it. The indentation is on this. But when you look front and top, you can't see it. So I didn't bother putting it on. But you can, or you may have a different plug, okay? Now, I've planned this out in terms of I've also done these curves, drawn these curves in, and I've measured where they are. So with this, I measured from this point up to here. Imagine there's a line there, and I put a little dot, and I did the same there, and I know that's where the curve starts. I've also measured here from what would be the edge there to here and to there, and I put a dot and a dot, and then I could add my curve in, and I could add my curve in, okay? I don't know if you can see, but there is a tiny little dot there and there. Then I would draw these out. I've also, just to save myself a bit of time, I've measured from there to there. That's there to there, and I've put a little line. And I've measured how big or long the length of this pin, of a 3-pin plug, and I've measured it and I've put a point there, okay? So, I'm going to start drawing. I may stop the video because I'm going to do this in 2 parts, but effectively you can see as I'm going along, I'm just going to fill in the blanks. As I say, it is like a puzzle. What parts can you solve straight away? I started off with this part here because that to me seemed the easiest point to begin with. And then I had my framework to draw the top and the front, okay? It's almost like it's very hard to go wrong when you've got that framework in place. You don't have to do a diagonal line and do it like this, but I find it does help. So I'm going to draw these out. Okay, and then you would imagine this one here, like so. Okay, so the measurement there to there, I have actually measured all these out, but I'm just going to say that, let's say that we haven't. So that actually is 10, that is 10 millimeters, so it would be obviously 20, wouldn't it? It would be 20 if we double it, because the scale is 2 to 1. So do 20 and you do a little point. And you know, because it's a symmetrical item, of course, it'll be 20 on this side as well. So we draw a straight line. Draw a straight line there. Again, I always say, if you're using a plastic ruler, make sure it's clear plastic. Clear plastic ruler is better when doing technical drawing than using either, a metal one is. I have in past videos used a metal one, I will admit, but it is a lot easier to just see what you're doing, really. So, again, let's see the thickness of these pins, and they are 5 millimeters. So, of course, then they're 10, aren't they? In this case, I'm just going to double check that. Check twice, draw once. I don't know if you've heard that saying before. Or check twice, cut once, we normally say, so we don't waste any materials. So I know that's there. This is here. I'm going to draw these quickly. like so. And there are indentations. If you look at the plug, it actually tapers in. So if you look there, you would have another rectangle and you'd have 4 lines. But for the purposes of this video, I'm going to skip that step. I may do it in between video 1 and video 2. So we'll make sure our lines are straight. And we know, what do we know? We know this line. I can draw that lightly. I'm going to draw it too long. I can measure this up. I can draw that lightly. These, we know they're up here. I'm drawing them all too long, and I'm drawing lightly on the page so that we don't make any mistakes. And if we do, we can rub out. Like so. Like so. Okay, so what do these dotted lines mean? Well, that dotted line there correlates with this point here, doesn't it? That goes up. So that means this one must connect. So if I'm doing this, I'm going to connect these 2 points. So I know it relates to that pin and that pin, okay? But this one, if you know a 3-pin plug, the reason this one is longer, the reason being when you plug it in, this one, the plug on the wall is locked. So this actually sticks out more so that it unlocks and then these 2 can go in, okay? It's designed deliberately that one's longer. So if we look at this here, well, we know that lines up, so it must be that line there which correlates here. So we get our ruler and we draw our line like so. Okay, then I know I no longer need these lines. Okay, so do that. Okay, and that's it. Of course, I rub out what I don't need. I put a slight, if you look at that plastic, there's a slight curve to the edge there, so I would apply a slight curve to these 4 points, like that, and I would draw this in again. I would go over it. I would go over these. I'd probably, let's see if I can catch that on camera, I'd probably draw these smaller rectangles in as well, where it's tapered, and I would draw these diagonal lines, 1, 2, 3, 4. I would place those inside the pins as well. Okay? That's pretty much it. I've also written all measurements are in millimeters. The reason I've written that is when we do our measurements, we only have to write our number. We don't have to write mm after each one. But we'll talk about that in the second video. I'm going to stop this now. If you want to get up to this stage, and then second video we'll talk about overall finish, thick and thin line technique, and then applying measurements. The thing about applying measurements is you don't need to keep repeating yourself. But we'll talk about that more afterwards. So it's putting measurements in as efficiently as you can. Okay, thank you, and stay tuned for part 2.